Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and welcome to this session on earned value analysis. Earned value analysis is a tool to monitor, evaluate, and control all the three basic constraints of a project, that is cost, schedule, and scope. Earned value analysis comprises a number of terms, concepts, and KPIs as shown on the screen. The ones in blue depict the status of the project, current status of the project, where the project is in terms of schedule, cost, and scope. And the ones in the red are the forecasts. One question that is often asked is, when is the best time to do earned value analysis? The answer is anytime. Earned value analysis can be done anytime. But a better time to do earned value analysis at the planned completion of activities and work packages or at planned milestones. But the best time to do earned value analysis is when the activities and work packages actually complete or the project actually reaches some milestone. That's the best time to do earned value analysis. As we do different exercises in this session, we will be doing earned value analysis at the actual completion of activities and work packages. The key word to understand in the concept of earned value analysis is value. What is value? Consider this project. This could be any project. It is only symbolic. It could be a software project. It could be a construction project. Doesn't matter. It has different activities as shown in different colors and shapes on the screen. If this project is broken down into its activities and work packages, call it work breakdown structure, then this is what it may look like. As you can see, every activity has an alphabet that is its name. The alphabet is followed by a figure, which is the activity duration. And the next set of figures indicates the cost estimates of the activity, including contingency reserves. If we now roll up these costs, we get a figure of 3,000. What is this 3,000? That is key to the understanding of this subject of earned value analysis. This 3,000 could be the project cost, which has certain implications, or it could be the value of the project. Consider these costs to be the values of these activities. For example, the value of the cost of activity D is 600. This is also its value. So if we now consider 3,000 in terms of values, we can say that 3,000 is not only the cost of the project, it is also the value of the project. What does that mean? Well, to start with, when we consider 3,000 to be the cost of the project, that means we have to stay within this cost. This is the money given to us. This is the budget given to us. And we have to complete the project within this cost. If we spend more, we will go over budget. And of course, we ensure this through the process of control cost, which we did last week. If we consider 3,000 to be the value of the project, then this value must be achieved. If this value is not achieved, then the project is incomplete. For instance, if activity D was not done in this project, then the value accrued in this project would be 2,400, and we would consider the project to be incomplete. So if 3,000 is the value of the project, this value must be earned. This value must be achieved. And this we ensure through two processes, control scope and validate scope, which had come under discussion about 3 weeks back. Another nuance of this term value, if we consider 3,000 to be the value of the project, is that we must not cross this value. This is the limit. The project must not earn more than 3,000 unless the project scope is revised. If the project scope is not revised and the project earns more than 3,000, that means the increase in project scope was uncontrolled. And what is uncontrolled increase to project scope? That is scope creep or gold plating. So we must avoid crossing 3,000. So this value of 3,000 could be project cost. We must remain within the project cost, otherwise we'll go over budget. We must achieve 3,000 so that the project is considered complete, and we must not cross 3,000 otherwise, unless the project scope is revised, in which case it would be a case of a gold plating or scope creep. So having understood this value, this concept of value versus cost, we can have a closer look at the subject of earned value analysis, how it is planned, how it is implemented. So what we are going to do is take the same project. What happens with any project? It is planned once the activities it is planned. We have this project, we know what the activities are. The next step is to draw a network diagram as shown. So as we can see, all the activities are in series except one, G, this activity G, which could be done in parallel once activity B has been completed. The same data is shown in the form of a table. We have the list of activities over here, their durations, and their estimated costs, including reserves. And if we add them up, we get 3,000, which is the cost of the project as well as the value of the project. The next step is to accumulate the time and costs. We assume that all the activities take place within the or complete within the given time, planned time, and they cost whatever is the budget allocated. If we consider time, once activity A completes, let's say the time unit is 4 is the time unit is days. So when activity A completes, 4 days would have elapsed. Activity B takes 6 days to complete. So when activity B completes, 4 plus 6, 10 days would have elapsed, and so on and so forth. Likewise, the cost. When activity A completes, 200 rupees would have been spent on the project. When activity B completes, which will consume 540 rupees, 540 plus 200, 740 rupees would have been spent on the project. So here we are. This column indicates accumulated time. And as can be seen, the accumulated time is 30, which is also, if you add up all these durations, minus the duration of the activity in parallel, we come to 30. And likewise, if we add up the costs, they will wind up to 3,000. And in this case, these are the accumulated costs. And the culmination of accumulated costs is the budget at completion, which in this case is both the cost as well as the value of the project. And we also know that accumulated cost is nothing but the cost baseline. In earned value analysis, cost baseline is also the planned value line. Why? Because we have already established that cost and the value are the same thing, but their connotations are different. So when we talk of cost, we talk of cost baseline. And when we talk of value, we talk of the planned value. This will become clear as we proceed further. So having drawn the network diagram, having established accumulated costs and accumulated time, it's time to draw the Gantt chart, which is shown on the screen. This is the timeline, and this is your Gantt chart. If this Gantt chart is baseline, this becomes your schedule baseline indicated in gray. One thing more that we can do on this chart is to plot the cost baseline, which is a little unusual, but it will make our life very easy when we do earned value analysis if we superimpose this schedule baseline with the cost baseline. This is our cost baseline. We already have a timeline. Please remember that both cost baseline and Gantt chart have a common timeline, and this is the timeline. Since it is common, we can afford to put the cost baseline on the same chart as the Gantt chart. So we can put this cost baseline on the same chart. We know that activity A is to complete after 4 days. So after 4 days, we can put a figure of 200 over here. After 10 days, we can put a figure of 740 over here. So this is what the situation will look like. We have now both the cost baseline, albeit in the form of a chart, not in the form of a line, but in the form of a chart, or in the form of a chart on the same chart. So what we have over here is the cost baseline sharing the chart with the schedule baseline. Another thing which we can do is divide this schedule baseline or break it down according to the time units. Since we are talking about days, let us see what is the effect of this cost baseline per day according to the activity. From 1st to 4th, activity A is taking place. 4 days. The value of activity A is 200. So per day cost or value of activity A is 200 divided by 450. So on day 1, we would expect to spend 50. On day 2, another 50, which is 100. On day 3, another 50, which is 100 plus 50, 150. And on day 4, another 50, 150 plus 50, 200. Considering the next activity, its value is 540, and it is spread over 6 days. So per unit day value is 90. So at the end of day 5, we would have spent 200 plus 90 in this case, because per day value or cost is 90. So 200 plus 90, 290, plus another 90, 380, and so on and so forth. And if we do it for all the activities, this is what it will look like. So this is our cost baseline. Now, further divided or broken down into time units. Rather than take time blocks, we have taken time units. On the next page, I'm going to take this cost baseline on top. We'll have this timeline, and then the cost baseline, and then the schedule baseline. And I'm going to get rid of this network diagram and this table. And this is what we have now. The timeline, the cost baseline, and the schedule baseline. And this is our ultimate shape of the project. At the same time, we are in the planning process. The project hasn't started. We can start developing the EVA chart. EVA chart is very important because charts are always very eye-catching. They give an instant status of the project and also the trend of the project. Where is it going? So we can start by creating this chart. This is again the cost baseline. As with any chart, it has two axes. Well, in this case, two axes: a time axis along the horizontal axis and the cost axis on the vertical axis. So we can transfer this cost baseline into its traditional form, which is a line, and this is what it looks like. Now, this is the cost baseline as well as another line. It has another name, and that name is the planned value line or the PV line. This indicates that as the project progresses, this is how the value of the project will be earned. If this is the cost of the project, this is the cost baseline, but this is also the value of the project. That means the project is going to get again its value along this line. What it means is that at the end of day 10, the project would have cost 650 rupees. It also means that at the end of day 10, the project would have earned 650 rupees worth of value out of an ultimate value of 3,000. So when we talk of cost, it is the cost baseline. When we talk of value, it is the PV line. Or you can also call it planned earned value line, or the way you plan to earn the value of this project. Of course, the culmination is the BAC, budget at completion, if you're talking about cost, or it is the value of the project, that is 3,000, which is depicted over here. While on the subject, let's also add the management reserves. We assume that the company's policy is to allocate 5% of the project cost as its management reserves. So 5% of 3,000 is 150. So those are the management reserves. When management reserves are added to the budget at completion, what we get is the project budget. So the project budget in this case is 3,000 plus 150 is 3,150. And the final thing is that this project is going to achieve its value of 3,000 at the end of 30 days, which was also the total of all activities minus those activities which are in parallel. So we can say that the planned project completion duration is 30 days, or the project will complete after 30 days. So this is the EVA chart which we have created, which we have created in the planning stage. And as this project starts implementing, we'll start adding data onto this chart as well. So let's now revert to our Gantt chart from a cost baseline which we had drawn earlier. We assume that the planning is complete and the project has started. Well, the project started 1 day late. That means instead of first, it started on second. Bearing in mind that the best time to do earned value analysis is when an activity or a work package actually completes. Our first earned value analysis would be when activity A completes, or this activity A in brown completes. Today is the sixth, or today the project is in its 6th day, and activity A has been completed. So this is the today line. Activity A has been completed. However, instead of taking 4 days, the activity A has actually taken 5 days to complete. And against an allocated budget of 200, it has actually cost 300 rupees. And because the project started a day late, and then this activity took a day longer than scheduled, overall, the project is now late by 2 days. So this lateness immediately pushes the project schedule forward. And now, as you can see, instead of completing after 30 days, it is now likely to complete after 32 days. So this is the situation as of day number 6, and let us do earned value analysis. Today is 6th day. We call this today line in earned value analysis as the actual time. So the actual time is 6 time units, and because we have already settled that the time unit is day, so actual time is 6 days. What have we achieved as of today? We have achieved, or we have earned activity A. But looking at the Gantt chart, when was activity A scheduled to complete? Well, it was scheduled to complete here, which is day 4. So day 4 is what the book refers to as earned schedule. So earned schedule is 4 days. Earned schedule is a somewhat confusing term. And in my opinion, it is better remembered as scheduled time or planned time. So we can say the planned time or scheduled time was 4 days. The actual time is 6 days. Now here we are, we can make an instant comparison. What we were supposed to complete in 4 days, we have completed in 6 days. It immediately tells you that there is a negative schedule variance. The project is behind by 2 days. While on this subject, let me make another point that you will find many formulas in earned value analysis. And while applying these formulas, it is always a chance to make a mistake, to change the sequence of numerator or denominator, or put the second figure first and the first figure second, and thereby ruin the solution. So my suggestion to you is to always apply logic and conceptual understanding. When you do that, you will never go wrong. So what I will do throughout this session is apply logic and conceptual understanding, and at the same time show you the application of formula, and you will appreciate that earned value analysis is easy when you apply logic or conceptual understanding. The conceptual understanding is that what we were supposed to achieve on day 4, we have achieved on day 6. So our schedule variance is negative 2 days. When applying logic or conceptual understanding, one way to do that is ask yourself a question and then answer that question. As this question has been framed, how long the project should have taken and how long it has actually taken, or it is a comparison between the plan and actual, plan time and actual time. Plan time was 4 days, actual time is 6 days. So the difference is schedule variance minus 2 days. And here is the formula also, earned schedule minus actual time, or planned time minus actual time, 4 minus 6 minus 2. In statistics, whenever you compare two things, you can do it in 2 ways. One through subtraction, as this has been done, and the other is through division. That is, instead of subtracting, you divide. So rather than subtract, you divide planned time by actual time, that is 4 days by 6 days. And then that ratio is referred to as the index. So index is both variance and index are comparisons. Variance is a comparison through subtraction, and index is a comparison through division or quotient. So what it says is that schedule performance index, the way schedule is progressing is 67%, or our schedule performance is only 60%. That means we are wasting 33% of the time. Because we are taking time units, therefore we are suffixing or we are subscripting these terms with TU. TU stands for time units. It is important to subscript or suffix them with time units because we can find schedule variance and schedule performance index in terms of monetary units also, as you will see shortly. So our first analysis, earned value analysis, suggests that this project is 2 days behind, and because A was a critical path activity, the whole project is late by 2 days. Now let me introduce 3 terms. One is the planned value, next is earned value, and the third is actual cost. Again, apply logic. Planned value. What was the value you had planned as of today? Or what had you planned to earn by today? That is the planned value. Or in other words, the question could be how much we had planned to earn so far. We can also call planned value to be the planned earned value. Now, if we look at the Gantt chart, today we are here, and as of today, what had we planned to earn? Well, we had planned to earn activity A in full and a portion of activity B. If you can see, activity A is spread over 6 days, call them 6 portions. And out of 6 portions, as of today, we should have completed 2 portions, 2 out of 6 or 1/3 of the activity. So what is the planned value? The planned value is we were supposed to complete activity A, whose value is 200, plus 1/3 of activity A, whose value was 540. So 1/3 of 540 is 180. So 200 plus 180, our planned value was 380. So as of today, we should have earned 380 value out of 3000. Have we done so? No. Why? Because what we have earned is activity A. Because this is the actual performance. This is the baseline. This is the actual performance. And what we have achieved, activity A. And what is the value of activity A? 200. We have achieved this. Its value is 200. So what we have earned so far, which this is called earned value, is 200. So we have planned 380, but we have managed to earn 200. Again, we are earning less than what we had planned. This gives you an indication of delay. And the final, the third figure, the third element is actual cost, where we have earned 200. But at what cost? Well, we have spent 300. We have spent 300 to earn 200. So our actual cost is 300. So keep asking yourself questions, putting yourself logical questions. And that is how you will get to full grips with this subject. If you apply the formulas, you're likely to make a mistake. So having found these 3 basic parameters, planned value, earned value, and actual cost, we are now in a position to make a few more comparisons. We compare earned value with planned value and get an indication, an inkling of time. And when we compare earned value with actual cost, we get an inkling of cost, budget. Where is the project going in terms of budget? So let's make the first comparison, earned value versus planned value. The question to ask is, what have we earned and what we had planned to earn? What we have earned 200. And what we had planned to earn, 380. So we have earned far less than what we had planned to earn, time. So we are behind time. This is referred to as schedule variance. And here, because we are considering monetary units only, therefore we suffix it MU, monetary units. Here we are. The question is what we have earned. We have earned 200. And what we had planned to earn, we had planned to earn 380. Or in other words, it is a comparison between EV and PV, EV versus PV, and we get minus 180. If we subtract, we get minus 180. But instead of subtracting, if we divide, we get an index. So schedule performance index is 53%. By the way, this is getting obsolete. This is now, this is virtually has superseded MU. So it is much realistic, much better to do in terms of time units than in terms of monetary units. But because it's in the book, so I thought I might cover it as well. I will cover schedule variance percentage shortly. I will not cover it here. So that was planned, that was scheduled. We can do similar exercise for cost by asking ourselves, what have we earned and at what cost? We have earned 200 at a cost of 300. What does that indicate? We are overspending. We are gaining less, spending more. Therefore, if we have to earn 3,000, we'll be spending far more than 3,000. So this yields a variance and index called cost variance. Question, what have we earned? We have earned 200. At what cost? At a cost of 300. So the variance is negative. We are over budget. We have to do something about it. And instead of subtracting, if we divide, we get an index of 67%. And again, I'll deal with schedule variance percent later. So this is what we keep doing as the project progresses. We have done it when activity A was complete. The next good time to do earned value analysis is when activity B completes. We assume project has gone forward and it is 12th day of the project and activity B has also completed. Activity B has completed in 6 days, and instead of 540, it has cost us 600. So let's proceed again. First, let's deal with time. This is the today's line, 12th of the project, 12th day of the project. So this is actual time. What we have achieved, we have completed activity B. Looking at the Gantt chart, when was activity B scheduled to complete? Over here. What date, what day is this? 10th day of the project. So our planned time or scheduled time, or as the book says, unscheduled is 10 days. Actual 10, planned, sorry, actual 12, planned 10. Behind schedule. The question to ask is, we have achieved something today, or let's say, whatever we have achieved today, when we were scheduled to achieve it. We were scheduled to achieve it on 10th day. What we have achieved today, day 12. Comparison, schedule variance time units, 10 minus 12 minus 2 unit. But if you're keen on applying the formula, it is ES minus AT. ES divided by 80 for the index. And if you are keen in formulas, please don't get the sequence wrong. Otherwise, your sign will be opposite, which will mislead you completely. What is the earned value? Earned value is, as of today, what we had planned to earn, for which we need to look at the Gantt chart or the schedule baseline. As of today, we should have completed activity A, activity B, and portions of activity G and C. How much activity G? Well, 1, 2, 3 days. So 2/3 of activity G should have been completed, and 1, 2, 3, 4, 5, 2/5 of activity C should have been completed. In terms of value, we should have earned 220 over here and 90 plus 90, 180 over here. So what is our earned value? 200 plus 540 plus 180 plus 220. And this is 1140. And as you can see, what does your timeline show you? What does your cost baseline or PV line show you? 1140. So that is the advantage of breaking the cost baseline into time units. It gives you instant planned value, and you don't have to make this calculation. Okay. We had planned to earn 1140. What have we actually earned? Well, we have earned just activity A and B. What are their values? Their values are, activity A's value is 200, activity's B value is 540. So what we have earned is 200 plus 540 is 740. So though we had planned to earn 1140, what we have actually earned is 740. Instantly, you can make out you are getting behind schedule because you are earning less than what you had planned. Coming to actual cost, okay, activities A and B have been earned, but at what cost? Well, activity A cost us 300, activity B cost us 600, so the actual cost is 900. Time to make comparisons. First of all, comparing earned value with the planned value to get a feel of time. We had planned to earn 740, we have earned 1140, we are way behind, so our variance is negative 400. And if you're keen on formula, it is EV minus PV. Instead of subtraction, division gives you 65%. If you compare earned value with actual cost, you get an idea where the project is going in terms of budget. You have earned 740, and in the process spent 900. Surely you're spending more. You are getting over budget, which is indicated by cost variance and cost performance index. So the project is behind schedule and over budget. What we are going to do, we'll discuss that later. But for the time being, this is the situation. And we haven't done any forecasting other than perhaps the schedule forecast, which is showing that the project will end up 2 days late. Okay, the next good time to do earned value analysis is when activities G and C, red and blue activities also complete, because they are in parallel. So let us go forward. It is day 17. And as you can see, activities G and C have also been completed. Activity G has cost us 300 instead of 270, and activity C has cost us 600 instead of 550. 600, 300. Let's look at the time. What is today's time? We are 17 days into the project, so actual time is 17th. What have we achieved today? We have achieved activities A, B, C, and G. Look at the Gantt chart. When should these activities have been completed? Well, they should have been completed A, B, C, G over here, day 15. Well, rest is easy. What we were supposed to complete in 15 days, we have completed in 17 days. We are behind schedule, -2. But if you're keen on formula, schedule variance in terms of time units is equal to ES minus AT. ES is 15, AT is 17, so -2. Divide them, you get an index of 88. But please do recall that this index is improving. On the previous slide, in the previous case, it was what slide is this? Okay, I don't want to disturb the slides. It is increasing. I'll discuss this in more detail subsequently, but schedule performance index in terms of time units is improving, and the variance is staying steady at 2. So after the initial loss, the project is proceeding at the required pace. But what has been lost in the beginning has not yet been recovered, for which you may have to do fast tracking, crashing, overtime, etc. The next thing to do is find out planned value. Well, our cost baseline instantly tells us that the planned value is 1,860. But let's work it out. What we were expected to achieve as of today? As of today, we should have completed A, B, G, C, and half of activity D, which is 300. So if we do this, 200, 540, 550, 270, and half of activity D, the result is 1860. So our planned value is 1860. Have we achieved 1860? No, because what we have achieved is these activities over here. And what are their values? The values are 270, 540, 200, 550, or as given on the Gantt chart, 200, 540, 270, 550. So this is our earned value, 1560. So we had planned to earn 1560, but we have actually earned 1860 behind schedule. Actual cost, well, we have earned 1560, but at what cost? Well, 300 on A, 600 on B, 600 on C. We are talking about 1500 and 300 on G, 1800. So our actual cost is 1800. We are overspending. Now, time to make comparisons. Comparing earned value with planned value in terms of monetary units will give you an indication of time. We had planned to earn 1860. We have earned 1560. We had planned to earn 1860. We are earning less than what we had planned. So a negative variance, as indicated here, -3 monetary units. Divide the two and we get 84%. Next comparison is earned value with the cost. We have earned 1560 at a cost of 1800. We are spending more. Therefore, we are over budget by 240 and our index is 87. And if you're keen on formulas, these are also shown. So we continue doing this exercise as the project goes on. Till such time the project finishes, we also do earned value analysis when the project finishes so that we can establish if the project is complete in the sense, real sense, in terms of scope. As we do this exercise, we keep transferring this data onto the chart. Remember, we had created the chart, so it is time to now So as we do this earned value analysis, we also transfer the data to that chart, and also some other charts for tracking purposes, which I'll cover later. So now let's look at that chart which we had created, which is this. Remember that? This is the chart. This is your cost baseline. This is also your PV line. Both nomenclature correct, but if you talk of cost, it is cost baseline. If you're talking of value, this is planned value line. We have done 3 earned value analysis. This is the data from the 3 earned value analysis. We first did data when activity A was completed after 6 days, then when activity B completed after 12 days, and when C and G had completed after 17 days. These were our planned values, these were our earned values, and these were the actual costs. We have already plotted planned value, and on these days 6, 12, and 17, the values 380, 1140, and 1816 are indicated. So 6, 380, and then for 12th 1140, and for 17th 1860. Let us now draw the EV line. EV line will look something like this: 6, 200, 740, 1560. This is the trend line. We'll come to that a little later. Now, instantly you find that the blue line is below the green line. Green line is the PV line. It shows you the scheduled pace of the work. You are below this, therefore you are behind time. It's much like the run rate. If this is the first team which batted and this is the second team which is batting, the run rate of this team is much less, much lower than the run rate of this team. So this blue line is green, below the green line. Ideally, it should be above, or let's say close to the green line. But here it is well below the green line. That means the project is behind time. Let us draw the today's line. This is the today's line, 17th, or this is the actual time. Okay, we have achieved 1516 today. When we should have achieved 1560? Well, all we have to do is go horizontally and hit the green line. This is also 1560. This is the planned 1560. This is the actual 1560. If you now look down, the planned 1560 was after 15 days. The actual is after 17 days. So this is your earned schedule or planned time. This is your actual time, and this is your scheduled variance. So if your planned time is to the left or behind the actual time, you are behind schedule. So this is schedule variance in monetary units. You can also find out schedule variance in monetary units, in which case, rather than go horizontally, you go vertically. And then you see that you, as of today, you have earned 1560. What you should have earned was 1860. So your schedule variance is this minus 300. You are earning less than what you had planned. So depending upon whether you want to find out schedule variance in terms of time or in terms of monetary units, you either go horizontally for time units and go vertically for monetary units. Now let us see this trend line. Trend line, as we have discussed a number of times in the past few weeks, gives you or tells you about the future based on your current situation. This trend line, which has been drawn by the Excel sheet, not by me, shows that if you continue to do this project at this pace, Then if you regress this line to a single line, this is what the situation will look like if it is a straight line. By the way, it is not a must that you have a straight line, but for the sake of simplicity, I've taken it to be a straight line. It could be any curved line, polynomial line, logarithmic line, doesn't matter. For the sake of simplicity, I've taken a straight line. So if the project continues at this rate, then this line can be regressed, or this line can be folded into a single line, into a single trend line. That means this then becomes your earned value line, de facto earned value line. And what value do you have to earn on this project? 3,000. So you keep going on this line and see where does this line reach 3,000. Over here, it is 2,000. Over here, it is 2,500. Keep going, keep going, keep going. And here we are. At this point, the project gains a value of 3,000. But what is this value in terms of time? Look down. It is 35. So that means this project is going to complete in 35 days. Schedule forecast. Remember, the output of control schedule process is schedule forecast. So your schedule forecast is 35 days instead of 30 days. So here is the situation that we are going to reach 3,000 over here, and we look down, we get a figure of 35. This is called EAC time, or earned or estimate at completion in terms of time, which is the schedule forecast. And the difference between these two times is the variance, and because this variance is the completion of the project, so it is referred to as variance at completion. So variance at completion is 5 days, and because we are going to be late, it is -5. So that was time. Let us now take cost and plot actual cost. Here we are. Again, just by looking at this graph, we find that the red line is above blue line. In other words, we are earning less and spending more. A clear indication that we are over budget. So that is the beauty of creating a chart and not taking tabulated data. So we do the same exercise as we did for schedule. If we compare the red and blue lines, we have earned 1,560 at a cost of 1,800. So that is straight away our cost variance. And because we are overspending, our cost variance is 1,560 minus 1,800 minus 240. And just as we had a trend line for earned value line, or earned value line, we have a trend line for the actual cost. That means if you continue to spend on the project the way you have done, then you are likely to follow this line. Now, this line can be collapsed, the spending line can be collapsed into this straight line. Now, this also has implications. And please see this carefully. Compare the red and blue line right from the beginning, from the first earned value analysis. We earned 200 at a cost of 300. And if we see it over here, we see we earned 200 at a cost of 300. So from 200 to 300, an arrow going up. We earned 740 at a cost of 900. 740 at a cost of 900 going up, arrow going vertically up. In the third analysis, we found that we earned 1,560 at a cost of 1,800. 1,560 at a cost of 1,800, arrow going upward. what will it cost us to earn 3,000, depending, bearing in mind the direction of the arrow going upward. Where do we reach or where do we achieve 3,000? We have already established that we reach 3,000 over here. So if we reach 3,000 over here, how much we would have spent? Go vertically and you get to this point, just as we did over here, up, up over here, we reach here. And if we look left, what value do we see or what cost do we see? 3,500. So the end of project cost is not going to be 3,000, but 3,500, the cost forecast. And how is it shown graphically? So from here, we hit the line vertically up, because why from here? Because this is the 3,000 point line, and we hit the cost line, look left, and this is our estimate at completion cost. And this is and the difference between the two, budget at completion and estimate at completion. This is variance. This is the variance at completion at cost. So this is your estimated completion cost. This is your estimated completion time. This is your variance at completion cost. This is your variance at completion time. Of course, the graph will instantly tell you the situation if the blue line was above the red line, or the red line or the blue line was above the green line. So obviously, you will have to interpret the graph accordingly. Now let's take the subject of earned value analysis to further forecasting. And further forecasting is done through KPIs called TCPIs, to complete performance index. Okay, these KPIs tell you whether or not you will be able to complete the remaining project within the remaining funds, or if not, then how much more funds do you require? So concentrate on this graph. If I ask you how much work has been completed, or how much out of 3,000 you have earned, obviously your answer would be 1560. How much more you have to earn? Well, you are required to earn 3,000. You have already earned for 1560. So how much more you have to earn on the project? 1440. Another way of saying the same thing is how much of the project has been completed in terms of value. Well, the work completed is 1560, and how much work remains? 1440. So how much work remains is from this line to where we have to reach, that is here. So this distance is your work remaining. If I ask you how much funds remain, well, you were given 3,000. How much you have already spent out of these 3,000? 1,800. So how much funds remain? Simple subtraction, 1,200. And on the graph, we will indicate from this line to this line. This is your funds remaining. Now, clearly, in this case, you see the funds remaining line is much shorter than the work remaining. So obviously, you cannot complete the remaining work within the funds remaining. So how much money do you require to be able to complete the project? We have just seen that this graph is giving us a figure of 3,500. So this project will be completed in 3,500. How much has already been spent? 1,800. How much remains? 3,500 minus 18,000. So that is 1,700. So how much funds are required to complete the project? Well, 3,000 minus whatever has already been spent. 3,500 minus what already has been spent. 3,500 minus 1,800, 1,700. And that on the graph is indicated from here to here. Now we can consolidate our concept and bring out the indices, which I have already referred to as to complete performance index. First of all, how much work remains? Well, 1440. We have just established 3,000 minus what we have already achieved. And how much funds remain? 1,200. 3,000 minus what we have already spent. So this comparison of work remaining with the funds remaining is called TCPI. And because we are making comparisons with respect to BAC, we call it TCPI at BAC. So our funds remain, our work remaining is 1440, our funds remaining are 1,200. We divide one by the other and we get a figure of 1.2. Normally, indices are good if they are greater than 1. But in this case, in case of TCPI, an index of greater than 1 is a bad news. What it tells you is that if you are to complete the remaining project within the remaining funds, you have to spend money at an efficiency of 120%. That means you spend 100 rupees and get 120 rupees in return. Obviously, this is easier said than done because we are already overspending. At the most, what we can do is complete the remaining project in the remaining budget. Surely it is not possible to retrieve these costs back. So 1.2 is a bad news. It should be less than 1. So TCPI BAC is a comparison of how much more work you have to do and how much funds remain. It is just like that you are going from point A to B. And the distance from A to B is 100 kilometers. And the fuel in your tank is for 60 kilometers. Will you be able to reach point B? No. And if you divide 100 by 60, you will get a figure of 6 1 is 6 4 1.7 or so. So your TCPI BAC will be 1.7. So you cannot reach because your TCPI is bigger than 1. If you were to apply a formula, then work remaining is BAC minus EV and funds remaining are BAC minus AC. So you can apply the formula, but I again stress apply concepts, apply logic. Earned value analysis will be very easy. You're going to get bogged down with formulas. Okay. What if you are provided with these 500 rupees extra? Now, how much funds will you have if you are given this variance at completion, which is 500 or extra 500, as indicated in the graph? Then how many funds do you have now? 1,200 plus 500, 1,700. What is the work remaining? 1,440. What the fund remaining? 1,700. You have more funds than the work remaining. Therefore, you will be very conveniently completing the work within those funds. So that gives another TCPI. Work remaining compared to funds allocated, additional funds allocated, or in other words, this thing over here, which is called estimate to complete or funds required. So when you make a comparison of work remaining with funds required, then it is a TCPI with respect to EAC because now this is becoming the reference, not BAC, because you have been given this extra. So your TCPI EAC is a comparison of work remaining with the funds required. So it is 1440 divided by 1700, and you get a figure of 0.85, which is less than 1. That means you will conveniently complete the project in 1700 rupees. Again, if you are formula geek, then the formula will be TCPI EAC is equal to BAC minus EV divided by EAC minus AC. So that would be the formulas. What I'm going to do now is put all the previous calculations, KPIs, etc. on the same chart as shown. And now on this one slide, you have all the earned value analysis concepts explained fully. This is one master slide or page in which everything you need to know about earned value analysis is depicted. Okay, I had left out the concept of percentage variances, if you recall, percentage or percent schedule variance and percent cost variance. So let me now deal with those. Consider these two projects. Let me take this picture away. Project A, value 200, project B, value 500. And today, this is the today line, meaning thereby that this project was to complete, both these projects were to complete today. Okay, let us see what the situation is today. Well, as of today, project A has earned 100 and project B has earned 400. Let us take simple variances, schedule variances first. What is the schedule variance in case of project A? The project A has earned 100, whereas it had planned to earn 200. So what is the variance? Minus 100. Project B has earned 400. It had planned to earn, as of today, 500. So variance minus 100 again, as indicated in these calculations. By the way, the first figures are EVs and the second figures are PVs. So in both cases, the scheduled variance is minus 100, meaning thereby that the performance of the two projects is the same. But come to think of it, is it? Is the project progress really the same? Well, this project is only halfway complete, and this is almost complete. But the variances show that the progress is the same. This is misleading. This is misconception, and this misconception is reduced by taking not simple variances, but percent variances. And what we do to find percent variances is to index these variances to the planned values. What is the planned value in case of A? 200. So we index minus 100 to 200 and we get a figure of minus 50%. We index 400 to its planned value, which is 500, we get a figure of 80%. Sorry, 20%. So when we index this minus 100 to the planned value, which is 200, we get minus 50%. And when we index this minus 100 with its planned value, which is 500, we get 20%. So minus 50%, minus 20%. The progress of this is 80%, the progress of this is 50%. Of course, 80% is better than 20% or 50%. The progress of this project is much better. So schedule variance removes that misconception created by variance being simple variance being equal. Similarly, the cost. We assume that project A has earned 100 at a cost of 150, and project B has earned 400 at a cost of 450. Again, the simple cost variances are the same, minus 50, showing that the cost performance is the same. No, this project has lost 50 when it is almost complete. It is almost through and it has lost 50, and this has lost 50 halfway through. So surely this is misleading, and to remove this misconception, the variances are indexed this time to earned value, not planned value, earned value. So minus 50 is indexed to the planned value over here. What is the planned value? 100. So this will become minus 50% again. And this minus 50 is indexed to this earned value over here, which is 400. So 50 upon 400 would be at 12.5%. So this is the situation. The schedule variance over here, percent cost variance over here is minus 50%, over here is minus 12.5%. This, of course, is much better performance than this. Therefore, we use percent variance. One final point, we index this to planned value and we index this to earned value. Don't please get it other way around, otherwise you will get the entire solution wrong. Okay, whatever I have explained to you is summarized on the slide in this text. So please go through it in your own time. I will now present to you a special case, and that special case is earned value analysis done at the end of the project. Consider these 4 projects, and as indicated by the green line, all these 4 projects have the same cost-based line, same PV line, and same durations. So all these projects have a budget of 120, call it million rupees, 120 million rupees, 120, 120, 120. And all these projects are scheduled to complete in 6 months, 6 months, 6 months, 6 months. Let us now deal with the earned value analysis done, the final earned value analysis done for each of these projects. Take project A. Let's take the scope first. This project was required to earn 120 million rupees worth of work. How much has it earned? 100. That means this project was handed over for some reason incomplete. The customer would have been in a rush, or there could have been some other problem, but this project was handed over unfinished, incomplete by 20 million. That means 20 million rupees worth of activities were not done on this project. So that is the scope. Time. The scheduled completion time of this project was 6 months, and it was handed over after 6 months as indicated by the PV line. So the project was handed over on time in 6 months, but of course incomplete. Cost. The project cost was 88 million. Now this can be looked at in 2 ways. You were given a budget of 120, the project got completed in 88, so the saving is 32, 120 minus 88.32. But if you consider what you have earned, then the saving is really 100 minus 88. Either way, it is correct, so long you can explain. So the saving could be 32 or 12, depending upon what figure you are taking, 120 or 100. So all this is summarized over here. Take this case, project B. The project was to earn 120. How much it has earned? 140. Increase in project scope. Is it regular increase in project scope or irregular or uncontrolled? Well, clearly the PV line is stopping over here. That means that was the scope. So either some scope creep took place over here or gold plating took place. So this project went over scope by 20, either through scope creep or gold plating, but not through regular increase in scope. Let us see the time factor, time schedule. This project was to complete in 6 months. It completed in 7 months. So 1 month late. Cost. The budget allocated for this project was 120. The project has spent 160. So over budget by 40. However, if you look at the earned value, of course, this project has greater earned value now, 140. Then you can say it went over by 20. So again, it depends whether you consider this value or this value, but you have to explain. It is better if you consider this value, the budget given to you. You have overspent by 40. Otherwise, if you consider what you have earned, then of course it is 20. So all this is explained over here. This project was supposed to earn 120. How much it has earned? 120. So it finished perfectly according to the scope. No scope creep. The project was fully complete. Nothing was missed out. Time, this project was to complete in 6 months, and PV line, so the EV line shows culmination at 6. So it was handed over in 6 months, no delay. What about cost? Budget was 120. The project spent 150. So this project went over budget by 30 million. Explained over here. Final project was supposed to earn 120. And how much did it earn? As indicated by the earned value line, it did reach 120. So this project too finished according to the scope. No less, no more. No gold plating, no scope creep, and complete project. Time, this project was to be completed in 6 months. However, it completed in 7 months, so it was late by 1 month. Cost, this project earned 120 at a cost of 96, so it made a saving of 24 million rupees. So all this is explained over here. We have 4 small topics left to be discussed. So let's do that also. The first is this cost forecast, estimated completion cost. We need to have a deeper look at this concept of EAC cost, which is nothing but the cost forecast. From the graph you saw, the graph gave a cost forecast of 3,500. That is the graphical treatment. But there can be numerous other situations which can dictate some other cost forecast, not 3,500. And I'm going to go over those situations one by one. And it is important for you to understand those. There is no final word on EAC cost. It will be your judgment, your expertise as to which is the right methodology to work out this very important cost forecast, because your management will be asking you, how much is this project going to cost? So you better come up with the correct rationale and correct methodology. One we have already seen in the graph over here, you saw 3,500 EAC cost. But let's now see other methods. This is the data which I picked up from our previous earned value analysis. Remember, the budgeted completion was 3,000. The last indices were 0.87 and 0.84. The last actual cost, the money we had spent was 1,800. The last work remaining was 1,440. And the last TCPI at BAC, sorry, I forgot to put suffix at BAC. The last TCPI BAC was 1.2. And let's see what else we can do. The last performance, cost performance was 0.87. You could either take the last cost performance or take the average of all the previous cost performances, and you can apply these cost performances on to the budgeted completion, particularly if your project is progressing at a steady rate and get an end of project cost. So what it means is you simply divide 3,000 by whatever index you have got, either last index or the mean of all the previous indices, and that will give you some other figure. So when you apply 87% on 3,000, you get this figure as the EAC cost. Then again, logic. You have already spent 1,800 out of 3,000. Your work remaining is 1,440, and you tell your boss or the head of the PMO or the project sponsor that, look, whatever has left my pocket has left. It is not going to come back. 1,800 rupees are not going to come back. They are gone. They are sunk. But what I promise to you, what I commit to you, is that I will complete the remaining work in the remaining budget. What is the remaining work? 1,440. That is also the remaining budget. So I promise to complete the remaining work in the remaining budget. That means in 1,440. So the end of project cost will be nothing but add the two, and you will get a figure of 3,220. So that is another logic. 1,800 plus 1,440, 3,240. So what has been spent has gone, and remaining work to be completed in the remaining budget. Well, again, conceptual understanding. If you want to apply the formula, here is the formula. EAC is equal to AC plus BAC minus EV, and apply these figures and get the answer. But logic, conceptual approach is a good approach. Okay, then you can have if this was a risk-taking project manager, you could have a risk-averse project manager who would say, look, the work remaining is 1,440. I make no promises to you that I'll be able to complete the remaining work in remaining budget. Sorry, no way. Why? Because the CPI is 87. At it, I'm already overspending. How can I promise to you that I'll complete the remaining work in the remaining budget? Not only that, I'm also behind schedule, and time is money. So if I'm behind schedule, that means I require more money. So sorry, no promises. What I will do is I will apply these two indices, which are depictive of the cost and schedule performance, onto the remaining work, and whatever I get is the answer. So here we are. 1,800 has left my pocket. Work remaining is 1,400. and apply both indices, and you get a very hefty figure of 3,770. And again, these two figures tell you this is a bloated figure, risk averse project manager. This is a very conservative figure, risk taking project manager. Again, which approach is correct? Whatever you say is correct because you are the professional project manager. Another approach could be to forget about indices and work remaining, but involve instead the TCPI. What is the TCPI telling you about the remaining work? The TCPI is telling you that the remaining work is to be completed at 120% efficiency, or you need 120% funds to be able to complete the remaining work. So again, the same logic. What has left your pocket has left. 1800 left your pocket, so it has left. Remaining work is 1440, so apply TCPI on that, TCPI back on that, and you will get this figure. So, sorry, 1440, apply TCPI back, and you get a figure of 3528. Or there could be a simpleton project manager. He says, I don't like many calculations. The point is, you gave me a budget of 3,000. The TCPI is telling me 1.2. So simply apply 1.2 on the back and give me the money. So when you apply 1.2 on the back, you get 3,600. And finally, when you find that you are really way above the budget, there's something wrong happened with planning at the planning stage. Most probably your estimates were incorrect. So you would like to redo the estimates. Which estimates? Estimates of those activities which are remaining. You cannot re-estimate what has already completed. So 1880, which refers to the completed works, you can't do anything. But for the remaining 1,440 rupees worth of activities, you want to see if those estimates were correct. And you redo the estimates. And therefore, when you redo the estimates, instead of 1440, it comes to 1750. So you add 1750 to what you have already spent and get this figure. So these are the various approaches for working out the cost forecast, also called EAC cost in the language of earned value analysis. The next topic is tracking. It is always useful to track indices and variances, but there are a lot of them. What indices and variances you would like to track? When it comes to schedule, it is a good idea to track schedule variance and schedule performance index in terms of time units, not monetary units. Monetary units are in any case going out, they're getting obsolete. And it is always good to track cost performance in terms of percent cost variance and cost performance index. Let's see a schedule first. A simple graph. Take variance on one side, and index on the other side. This is major axis, major vertical axis. This is the minor vertical axis. So variance 0. This point represents a variance of 0 and an index of 1, and you plot these. When it comes to this schedule variance in terms of time units, you find that it is -2, a steady line parallel to the ideal line. Of course, you have to catch up with this line. These two lines must catch up with these two lines. What does this tell you? This tends to tell you that you are keeping pace with the project. But perhaps initially, you lost 2 days and you have not been able to recover those 2 days. Otherwise, because you are now performing all the activities within the scheduled time, the index is getting closer and closer. But if you do not take any corrective action, it will get closer and closer, but it will never touch this. You will remain in error. So if you want to regain these 2 days, you have to do some crashing for fast tracking, added shifts, overtime, etc. So that you have to turn this line inwards so that this line can go and hit the ideal line. So this is schedule tracking. If you're not clear about this, we can discuss this more in the class. But the point is, the index line must hit this line, but in this particular example, it will never hit. It will stay aloof if no scheduled compression technique is employed. Here is the case of cost variance. This is very different from this. Here, both these lines are heading. They're heading towards the center line, but they will never touch this line because the money which has left your pocket is not going to come back. They will get closer and closer. It only shows that you are initially not very careful with spending money, but as the project is progressing, you're becoming more and more cognizant, and therefore these lines are getting closer and closer to the ideal line. My last message on this slide is you have to get closer to this line to be able to complete the project within not exactly the baseline or on baseline, but reasonably close to the baselines. Another problem worth discussing is how to find out EV and PV quickly for those projects which proceed at a steady pace. There are many projects which do that, particularly construction project. If you are laying a gas pipeline, of course, it is being laid at uniform rate. Let's say 10 kilometers a day, and therefore you can make quick estimates of earned value and planned value. If you are tunneling through a hill or a mountain, again, those machines have a certain rate of tunneling, maybe kilometer a day or whatever is the metric used over there. So in that case, it is useful if we can work out earned and make quick estimates of earned value and planned value using simple arithmetic techniques. Consider this example. On a certain project, 200 kilometers of oil pipeline is to be laid in 50 weeks. So scope is 200 kilometers, project duration is 50 weeks. At a cost of 2,200 monetary units, so BAC is 2,200. Assume the rate of laying the pipeline to be uniform. Today, at the end of week 20, so time elapsed is 20 weeks, 90 kilometers has been laid. So earned value in terms of deliverables is 90 kilometers. What is the PV and EV? Okay, there are two methods. One is very easy, which I'll discuss later. And one is what you may prefer, and that is to find out quantities per unit. How much pipeline is being laid per day, and what is the cost of pipeline per kilometer. Here we are, 200 kilometers in 50 weeks. So it is 4 kilometers per week. And then it is 2,200 monetary units for 200 kilometers. So it is 11 monetary unit per kilometer. This is what I was talking about, taking units taking quantities per unit. So here it is per unit time, and here it is per unit deliverable or per unit kilometer. The rest is easy. If we have worked out these two quantities, the rest is easy. So what is the PV? Well, PV is how much work was supposed to complete as of today. As of today, 20 weeks have elapsed, and in each week, 4 kilometers were to be laid. So 4 multiplied by 20, 80 kilometers. So our PV is 80 kilometers, but in terms of deliverable, not in terms of monetary unit, but which we will come to later. So the work planned is 80 kilometers, and what we have achieved is 90 kilometers. So we are ahead of time. So earned value in terms of deliverable is 90 kilometers, and planned value in terms of deliverable is 80 kilometers. But we know the cost of 1 kilometer. The cost of 1 kilometer is 11 million rupees, for example. So what will be the cost of 80 kilometers? 11 multiplied by this, 880. So 880 million rupees is your planned value. And since you have completed 90 kilometers, cost of one is 11. So 990 is your earned value. Simple. But an even simpler way is just to consider BAC. The BAC is 2,200 million rupees. Apply the time proportion to get PV and apply the deliverable portion to get the EV. What do I mean by that? BAC is 2,200. What is the time proportion? 50 weeks allowed, 20 weeks passed. So simply, this is the time proportion or fraction of time completed. And if you multiply, you get 880, as was the case here. And for EV, you apply the fraction of deliverables completed or fraction of work completed. What is the fraction of work completed or deliverables completed? 90 kilometers out of 200. So apply 90 out of 200 on BAC again, 90 out of 200 on BAC again, and you get 990 million rupees. So that is your EV. So two methods, both. This one is particularly easy, but you may find this one more appealing. It's up to you. And the last topic for today or for this session is what to do if you end up in an adverse index situation, whether it is cost performance or schedule performance index. Okay, you have to look at the tolerance. We assume that a tolerance of 10% is allowed. Then these are the three situations where CPI or SPI, either index, is 0.95. As you can see, 0.95 is within 10% tolerance. Therefore, no action is required. So if your project is yielding a CPI or SPI of 0.95, no problem. Be happy. Consider 0.91. It is inside 10%, but it is close to the limit. Therefore, you will like to take some preventive actions. That means some actions to prevent whatever you are doing from slipping, either in cost or time. Look at this figure. This is way outside the tolerance limits, so you have to take some corrective actions. So with that, we come to the end of this session.